All right, good morning, good afternoon, or good evening, depending on where you're joining today. I'm Christian Gilby and excited today. We're going to be talking about Wi-Fi and CBRS, a bit of a technology primer if you're not familiar, as well as how the technologies can work better together to give you a better experience across your network for your customers, your employees. And today, if you can jump to the next slide, we are joined by Bob Galt, who's Chief Commercial Officer at Geoverse, and Bob Friday, who's the CTO and founder of Juniper Mist. So if you can jump to the next slide. What we're going to talk through is a little bit of an intro. Talk a little bit about the Juniper Experience First Network. I'll run through that, and then Bob Galt's going to actually walk through a little bit of a background on Geoverse. And then we'll get into the technology. What is CBRS or private cellular? What are some of the use cases that really make sense to leverage this technology, where it makes sense to use CBRS and where Wi-Fi is the better fit? So I think it's really complementary technologies here. And then what are we doing together in terms of how Juniper Mist and Geoverse are delivering a great solution together. I'll definitely say make sure after the webinar or as we're going through it, there are some handouts on the GoToWebinar platform you can download. For example, we have a joint solution brief, some technology case studies about the products, both on the wired wireless side and on the CBRS. And then we'll jump into Q&A. If you have any questions as we go, enter them in the question panel for GoToWebinar. And then at the end of it or along the way, we'll get to those questions. So with that, jump to the next slide. And I just wanted to set a little bit of a context on what we're delivering at Juniper, driven by Mist A. It's really about the Experience First network. So shifting away from focusing on the boxes or the network itself to how we can deliver a better experience for both your end users, customers, but also your IT team. And how do we do that? We do that in a few key areas. So the pillars that we build on is really around assured user experiences. So we leverage over 150 pre and post connection states to understand what's the experience of the client, the IoT device, the application, so that one, we can understand, like as an IT team, how the experience is, but then leveraging Marvis and Mist AI proactively when there is an issue, either fully self-correct that, or at least flag as an issue so you can proactively investigate it. We build it on a modern microservices cloud. Why does this matter? If you look at the industry today, all these devices coming in, I mean, mobile's been a trend for quite some time now, but IoT, you've got new IoT devices coming every day. And I think even in the past year, this has been even amplified even more, where you might have your IT team remote from your employees. Maybe they're working at home or the IT team's remote. I think it's critical to leverage a microservice cloud. So you've got that agility, you can scale up and down services, and then be able to roll out updates on a weekly basis without downtime. So that is the power of the platform. And then ultimately what we're evolving to is the self-driving network and automation. You want the system, when it detects an issue, to actually go and resolve it where it can, or at least to flag it for your IT team so that, let's say it's some third-party system that it can't resolve, be able to actually go and root cause it so your team can deliver that. And then finally, we build on top of a threat aware network with our connected security. When we detect a threat, we're actually able to, at the edge of the network, enforce that so you can limit risks of the network, because it's becoming more and more pervasive as the edge of the network moves to the mobile device. So with that, let me turn it over to Bob, who's going to run through a little bit of a background on our partner, Geoverse.
Thanks, Christian. Appreciate it. And thanks for getting us kicked off. I thought I'd start the first slide off with just who's Geoverse. I'd be really impressed if many of you on the call heard of Geoverse. But we are we're an established company. We have a cellular heritage. We have a cellular expertise. We have about 350 people on the team. We have 500 plus locations. And in those 500 plus physical locations, we have about 1,200 cell sites or macro towers across the United States that are deploying technologies like GSM, CDMA, UMTS, and we have lots of LTE that's deployed as well across those cell sites. We have users of about 1.2 million north of that. They're consumer. and commercial and enterprise customers. And we happen to be in a very good situation because there's a number that's not on this slide, and it's north of 90. Because we're a subsidiary of a company called ATN, who's a public company. It's Atlantic Telecommunications Network. And we're in a pretty good situation where they're a VC, but they're also telecommunications and a communications company. And so as a result of that, they have numerous business partnerships and commercial relationships with many of the providers across the United States. And in those commercial agreements, they have what's called roaming agreements, bilateral agreements with the service providers, and that's 90 plus bilateral agreements that we have with those providers across the United States, because we're able to draft off of the commercial agreements that ATN has established, being a subsidiary of them. So a pretty good situation. Really excited about the fact that ATN has really made an investment to double down in private cellular networks as we move forward into fiscal year 21 and continue to invest through this year and going into 22 and so on. So that's Geoverse very quickly. And then I thought I would just give you a quick CBRS 101. Just really, what is CBRS, which is Citizens Broadband Radio Service. And we're pretty fortunate because the FCC really gave us a kickstart and established the definition, which is a new wireless spectrum. It's a new wireless spectrum that operates in the 3.55 to 3.7 gigahertz range. And it's also known as, a band 48, where a technology like LTE can thrive within that band 48. So whenever you hear band 48 and CBRS, they're more or less one and the same. So a customer is getting as much as 150 megahertz of spectrum that's fully dedicated to them in a single venue. That single venue could be indoor, could be outdoor, it could be an enterprise or a community, which is providing an awful lot of capacity for a single customer in that single venue to get. And as you can see in the graph on the right-hand side, in some instances, it's as much capacity as many of the national providers are providing into an entire marketplace. So it's a new business model. It's a new shared business model where an end user organization could move forward with a private cellular network and operate that on their own, or they can actually look to a partner or a company like Geoverse to be able to operate that for them using spectrum that's lightly licensed and shared. And you'll be hearing things as you start to read more and see more about CBRS, you'll be hearing things about the OnGo Alliance. And the OnGo Alliance is really, it's a who's who of companies, established companies that make up this alliance board, and they're basically shaping the direction of CBRS. They're creating the standards, the compatibility with global networks moving forward. So I'm saying that because CBRS, it's going to be here, it's going to be around, and it's, we're moving in the direction of an open standard with lots of companies shaping things. And then obviously it creates a stepping stone, the stepping stone for 5G and other future features. And continuing on with the 101, there are three types of spectrum that are out there. There's incumbent spectrum, and incumbent spectrum is primarily designated for the US Navy, military, and it's really along coastlines for obvious reasons. But then it's also in designated areas, and that's for obvious reasons. So they have access to that spectrum. Then you'll hear what's called PAL licenses, or priority access licenses. This is license-based spectrum that many companies have, whether it's an enterprise customer, service provider, cable company, whomever it might be. Many of you on this phone might have spectrum on yourselves. And so a company like Geoverse has spectrum, which I'll talk a little bit more about. On the right-hand side are some of the companies and the investments they made in the auctions that took place at the end of last year, and they were awarded certain amounts of spectrum that goes across, and it's all county-based. There's 3,200 counties in the United States, and each of them have their own strategy in terms of where they were going to secure PAL licenses. And then there's generally available access, or generally authorized access of spectrum, and this is basically free. It's at no cost to anybody who wants to be able to use it. And the nice thing about this is it coexists with priority access license, and it does that because of all the work that a spectrum access server does in the background. And the Spectrum Access Server, think of it as a traffic cop or the governor across CBRS. And it's intelligently and dynamically allocating channels or spectrum to those who are requesting it. So for those who are getting it, they're assured of a quality experience that's consistent and across the United States. So that's the key role that it plays, so that each one of these different levels of spectrum can cohabitate or coexist.
And Bob, I may add, one thing I may add and highlight with the disruptive thing here is really this is the first time that enterprises can actually get spectrum to deploy cellular technologies without their mobile operators' help. So that's why the spectrum is so disruptive. Kind of reminds me of the early days of Wi-Fi. When we first had those unlicensed spectrum, same sort of scenario here. We're at the very early days of a new whole spectrum regulation paradigm.
Thanks, Bob. Keep giving me air cover, Bob. Thank you. And I talked a little bit about Geoverse and our investment in PAL licenses. So this is our footprint. So there's two things you take away from this slide. The first one on the left-hand side is that we can deliver a private cellular network solution to a customer. We can do it in the cloud. And we have data centers across the United States we'll continue to invest in that will align across the NFL cities. And then we can do it on-prem. That's two ways that a customer can secure a private cellular network solution from us. And also we secured PAL licenses that cover about 18% of the counties across the United States. We have, just south of 600 counties, about 7% of the US population. And really our strategy here was to make sure that we're securing PAL licenses that map to other areas of our business, but also map to underserved areas of the marketplace where for the tier ones to be able to play in those marketplaces, it's not really cost effective or efficient for them. So there's no real connectivity, efficient connectivity means for customers and partners in these areas, which is why we made the strategic direction to make an investment in those areas. And then it also aligns to key verticals that we all play on in this phone, including Juniper and Geoverse. And then there's elements to make private CBRS come to life. And many of you on the phone have a networking background. I've got a networking background for years and years and years. And you come over to private cellular and you recognize there's subtleties. There's just differences between how you turn up an architecture that's private cellular and how you turn up traditional enterprise networking architecture. The first starts with the core element, which is called an evolved packet core. Every network, every public network, every private network is required to have an EPC. Where Geoverse, our EPC is called GeoCore, and it's made up of Juniper. And we basically think of it as drop it into a container and put it into the data center or into our customer prem, and then we have our own industrialized software that we customize there. And then we have the base station. The base station is basically providing the signal source. And that signal source is providing signal source in a public network and in a private cellular network. That's the radio access network, or the RAN, that you hear this out there. That could be a company like JMA, Nokia, Ericsson, Airspan, Ruckus, whomever it might be. That base station is then providing a signal source to the end user devices. These end user devices could be tablets, mobile phones, scanners, whatever it might be. They're band 48 devices, and they're getting their signal source from the base station, which is under control of the EPC. And that base station is sending signal sources through a collection of small cells, or APs, low-powered small cells, or APs, that are then sending it to the end user devices. And then that's all being dynamically, or the spectrum is being dynamically allocated by that Spectrum Access Server. And companies that are generally providing the SaaS, the traditional ones that you see out there, are companies like Federated Wireless, Google, and there's also a CommScope, who's also a SaaS provider or a SaaS vendor. Now, that was in general the core elements of the CBRS network. This slide is how Geoverse delivers a private cellular network. On the far left-hand side is what I spoke about a little bit earlier, but this is actually the evolved packet core, the EPC. And in this EPC it's a Juniper intellectual property in there, so Juniper switches and firewalls. And then we use an industrialized software that we customize to make it carrier class so we can provide those roaming capabilities, so we can extend the coverage and the capacity to the tier 1 providers if a customer chooses to do so. We also then have the RAN and those collection of small cells and APs. And so we're an open and secure architecture. And what I mean by that is that whatever RAN a customer and or a partner choose to use, whether it's a carrier class RAN or enterprise class RAN, more than likely we have tested and certified it on our network so that we know it'll deliver a quality and consistent experience regardless of the RAN that you choose. That's the same thing with the end user devices. We then have the spectrum. That's the generally available access spectrum we spoke about earlier, or our PAL licenses. And depending on where you're at, we can map that to the counties of our PAL licenses. And then on the right-hand side is that connectivity. It's that roaming that provides the neutral host extension, coverage, and capability into the tier 1 provider. So what we're doing is in a single solution, a private cellular network, we're providing 2 key benefits, and we're providing a secure, high-performance network for your enterprise applications. And then we're also providing access to neutral hosting and multiple carrier subscriber support, all wrapped in a managed turnkey solution. We can provide a complete solution if a customer chooses that they want Geoverse to be able to drop in the radio, manage and monitor that, as well as the EPC, the SIM cards. We can do all that. Or if a customer chooses to do it with a partner, we're flexible as well. What's key for us is being able to provide a customer choice and flexibility. And then this is the, I'll say the landscape and how it's changing over time. And so a couple things that you want to get out of this. And so there are providers or ecosystem partners who played in the service provider space who are now making that transition by continuing to play in the service provider space, but making that transition to playing into the enterprise. And in that enterprise space, their value proposition is not only the RAN, but it's also bleeding into providing that evolved packet core to the end user customer. So when you hear that, and you hear the other pieces that are important to make sure that you're bringing the private cellular network to life, this ecosystem community is really important, because at a certain point, you have a customer who's actually, you have a company who's a partner in a certain scenario, and then you have a customer who's could be a competitor, depending on what the customer is asking for. At the end of the day, it could take an army to bring a private cellular network to life, or you can get a turnkey, total turnkey solution depending on the company that you go with.
Yeah, let me jump in here, Bob, and add a few things here. For those who are familiar with kind of the wireless LAN architecture in space, a couple of differences as you move into this 3GPP world is around the device ecosystem. In the wireless LAN space, we're used to our next generation technology being backward compatible all the way to .11b. In the cellular world, they tend to move from 4G to 5G in wholesale devices and infrastructure. So when you start to look into this private cellular option, you have to start with kind of the device ecosystem. And right now we're in the transition from 4G to 5G. Now there's an interesting thing happened as we move to 5G. In addition to the standards, there's something called O-RAN. So as the cellular industry is moving to their 5G technology, they're also moving to a much open standard architecture. But the 5G device ecosystem isn't quite there yet. And so this is kind of showing you all the different options as you start to look into your private cellular options. And what you'll notice right now is the big thing here is historically you've had to go back to your mobile operator to deal with cellular in any form or fashion. And what we're seeing in the landscape now, as enterprises are able to get spectrum, there's a lot of new players on the ground. There's a lot of new options for you to actually deploy private cellular. And Geoverse represents one of those, right? Where you really want someone to come in and act almost like a service provider for you. And that is what Geoverse brings to the table, is really that roaming, because they have roaming relationships with the operators to help you if you want to do neutral host roaming. There's other players like Cellular that are bringing kind of what I call the Meraki Mist Cloud story of the option, right? They're trying to simplify, cellular technology to look much more like Wi-Fi. And then we have players like Redis, Druid, and Ethernet. These are what I call kind of the do-it-yourself. We have some customers out there that are actually looking to actually deploy their own open source version of the network. And then we have the hyperscalers. This is the Google, the Azures. They're starting to look to be able to offer EPC packet cores as a service. So that's kind of the landscape that we're in place right now. And as I said, it reminds me of the early days of Wi-Fi. We basically have a whole new disruptive spectrum coming available, and there's a whole bunch of different ways to use that spectrum now that's available to the enterprises.
Bob, keep the mic. I'll hand the slide off to you.
Yeah, and I think the theme here today, we're talking about, for those who have been in the wireless for most of our career, we know that there's not just one single technology, right? Depending on what use case, what problem you solve, we're using Wi-Fi to solve some problems, BLE, Zigbee, LoRa. There's a whole bunch of different technologies available. This is just the latest in our toolbox. So going forward, we're going to be able to add private cellular to the enterprise wireless toolbox. And the next slide, Bob, we start to look at some of these use cases. And so I've been talking with, I think I've had like 40 different interviews with different customers, probably some of you on the call, on the webinar here today. And what we really found, you can kind of break them into 4 different buckets right now, what people are doing with this private cellular option. One of them is what I call IoT industrial. These are people like airports, ports, right? They want relatively low bandwidth and they need to connect devices. There's not much mobility between Wi-Fi and cellular, and they're looking for some way to basically get coverage, usually over an outdoor space, to industrial sensors. And these cases can range from simple connectivity coverage to what I call more complicated use cases that almost look like an operator use case. And that's where we get into this O-RAN 5G slicing technology that's coming down the pipe, where they want a lot more control on what they're doing with the spectrum. And then we have a variety of use cases that I say fall under what I call better together. This is like remote learning. We have a lot of partners out there. The government just released a lot of funding to go into underserved areas. This is, where we have students going from a school to home, and they're going to be moving between their Wi-Fi network at school to a private cellular network at home, either over a hotspot or directly onto a CBRS. And then the middle one here is neutral host, and this is where Geoverse actually brings a lot to the table. These are people who want to use the SIM card that's already in their employee's phone, right? This is a Verizon, AT&T, T-Mobile SIM card, and it's almost what I call the alternative to DAS. This is the indoor cellular option of, can we basically have people roam from their public cellular network to their private cellular network? And this is probably one of the bigger use cases we see coming out there is, hey, instead of putting DAS inside your building, can we leverage CBRS with neutral host roaming to do the indoor cellular problem? And then the third bucket we've seen a lot is really around customers who start to say, hey, I've got this indoor Wi-Fi network coverage, but I've got to provide coverage outdoors also. And they really want to provide coverage in a parking lot or around a distribution center. And so they want the best coverage, they want to leverage the coverage of CBRS with the best of indoor Wi-Fi. And these are probably the use cases that I'm focused on with our CBRS partners like Geoverse to really start to bring that better together AI ops story. As we roam from your CBRS network into your Wi-Fi network, can we provide that end-to-end flex, that end-to-end visibility and root cause? And now I'll turn it back over to you, Bob. We're going to go a little bit more down detail on some of these use cases, in particular, in a couple of different verticals we're seeing.
Yeah, thanks, Bob. And just to add on a little bit here, what you were talking about regarding remote learning, because we do have a couple of customers who they initially went down the path of remote learning to close that digital divide, but then it quickly bled into, because of the CARES Act money that's out there, accelerating the needs of a smart city. And so we're seeing that. We're actually, that's moving from paper to practical, where customers are making that investment across the city, like the city of Tucson, where they're using private cellular with Wi-Fi to improve things like traffic flow across the township, but also helping them with digital water meter reading across the city, so somebody doesn't have to go out and take a look at a water meter at every single home. With neutral hosting is a la roaming. I had a conversation with a customer the other day, and they actually talked about a new use case, which was, they wanted to avoid service interruptions during maintenance windows, so they're giving everybody roaming capabilities. So during their service maintenance windows, they have a backup plan, and then that's roaming. And then we have a customer up in, I'll say in New Jersey, who's using digital signage. They're using it indoor and outdoor. but in order to get across the entire parking lot, they would have had to dig fiber. It's slow, it's costly, so they're using private cellular's backhaul to Wi-Fi to fire up the digital signage. So there's a couple examples to hit on some of your points you made earlier.
Okay.
I thought I'd provide this as well, and this is basically, think of this as a cheat sheet by vertical, because of the great performance of private cellular and the private cellular complementing Wi-Fi, there's just so many different use cases that could come about as each one of these verticals. And just as an example, if you rolled your eyes and go to the right-hand side in healthcare, you can see we all know that healthcare coverage and capacity are extremely important because of the number of devices that are roaming around, the number of users, the type of equipment, and then you move from the type of devices to role space, whether it's nurses, physicians, patients. They all need access differently so they can get access to different things. So when you leverage, if you have any type of service interruption, it could be life-altering. So when you leverage something like private cellular as an overlay to Wi-Fi, it ends up becoming a really nice fit for healthcare. And then you've got manufacturing, you've got advanced manufacturing for robotics, logistics, inventory, and everything really requires low latency. And so CBRS could be a great architecture overlaid on top of Wi-Fi to address those latency concerns in advanced manufacturing, especially when you think about real-time inventory tracking with all the high volume devices that need to be tracked. And then lastly, it's things like transportation, where it's typically a huge geographic territory that needs to be covered for the users that are on the train, they're on the platform, and then all the reporting that's required per user. Because of the range and capacity and the coverage that private cellular offers up, it's a great overlay to Wi-Fi and the transportation vertical as well.
I might add, in the healthcare space, I'm working with one hospital right now where they're looking to use private LTE as kind of the voice for the nurses, and kind of in that use case where, yeah, I prefer LTE for voice, but I'll take Wi-Fi when I can't get it. So that's another example where we're seeing healthcare better together. They want LTE as their primary voice, but they'll take Wi-Fi, and then they want Wi-Fi for their primary data, but they'll take LTE when they can't get it when they're outside.
Yeah, thanks for bringing that up, Bob, because there are certain verticals where IP-PBXs are still prevalent, right? Whether it's healthcare, whether it's higher education. And so when they're looking for a single number service for a voice over LTE that ties into their PBX, and you almost get a borderless private PBXs where the features and the controls and all go with that mobile device as the user moves off the private cellular network into a public network, but as a SIM card, they can get a single number service with VoLTE tied back into the PBX. Some verticals are interested in that. Bob, I'm going to hand it off to you here.
Yeah, so this is my chocolate peanut butter, so we're going to dive a little bit deeper on 101 on Wi-Fi versus CBRS and kind of the details. So Bob, you move to the next slide. If I look at kind of the high level difference when you do side by side, what you'll see is Wi-Fi comes with a lot more system capacity, right? We have like 1.5 gigahertz, especially with the 6 gig band now. So Wi-Fi brings a lot more spectrum to the party than CBRS. It brings a lot more throughput. But what CBRS brings to the party is, depending on how you aggregate the channels, we have these 10 megahertz channels that you can aggregate together. You can bond them together to get more asymmetry. So you have more flexibility on up and down throughput with it. And so what I've seen most customers do, they will go in for like 100, 200 megabits per second down, and maybe 20, 30 megabits per second up. And they're basically optimizing for coverage. And that's probably the next big thing is what we're starting to see is people are starting to leverage CBRS for better coverage outdoors. Where it took maybe 50 Wi-Fi APs, they're starting to find they can cover a mile with one CBRS radio. You don't have the throughput, you're not going to be doing video, tons of video on top of your CBRS. But if you're looking to cover a port, that's fine, right? You got a few vehicles running around and some tablets running around in your schedule. The other thing, for us, connoisseurs and geeks out there, it's really the physical layer is pretty much the same now between Wi-Fi and CBRS or LTE. It's really the MAC that's always been the difference, right? In the Wi-Fi world, we have this listen before talk MAC. in the cellular world, they have the schedule MAC. So they tend to get much more deterministic latency, although that's becoming even true, somewhat less true in the 6 gigahertz band. And then finally, if you look where we are right now, cellular technology has typically been harder and difficult to deploy. On the Wi-Fi world, we've gotten down to these nice cloud managed zero touch provisioning, day one configuration, Marvis AI ops over the top of everything. We're just at the beginnings of that with CBRS, where we're basically simplifying the deployment model for cellular so the typical enterprise can deploy it just like they would along their Wi-Fi network. And probably the main difference is Wi-Fi has got, a 20-year mature ecosystem of devices. And that's probably the thing I highlighted before. When you get to the cellular world, that ecosystem has to be started from scratch every time. 3G devices get deprecated out over like a 5-7 year period. Then we move to 4G. And now we're moving to 5G. And that ecosystem of devices is just starting right now. So if you're doing an IoT project today, you'll probably end up deploying a private LTE 4G network just because of the devices you can get, because of the cost and availability of the devices. Next slide, Bob. And I think, the better together, what Juniper is doing right now, working with partners like Geoverse, is really looking at, can we bring that AI ops overlay, that single pane of glass, to both Wi-Fi and CBRS. So for those use cases where we are moving between a CBRS private LTE network that may be outside your store, or for that healthcare use case where we're trying to keep your nurses onto the LTE network for voice when we can, but moving to Wi-Fi, you still want to provide that same end-to-end visibility onto the app. And so that's kind of that paradigm shift from, 20 years ago when I was doing aerospace, it was about helping you manage boxes. Now we're in a paradigm here, we're really here to help you kind of manage the end user experience and the devices, all the way from the client to cloud. And that's what AI and Marvis is bringing to the table. And that's what we're working with Geoverse and others on, is how do we, provide that visibility across both of these networks as we move forward. And so this is the main use case we're working on. And I think both Bobs are highly interested. And anyone who wants to work on these use cases, directly reach out to us and we will be happy to sync up with you. Next slide. And this is probably the other big use case, and I see a lot of questions coming up in the chat over here around the roaming, right? And this is probably the biggest paradigm shift up to now. Is cellular and Wi-Fi historically have been two separate worlds. We've had the public cellular network, and then we've had these private Wi-Fi networks, and now we're starting to have private cellular networks. And we had the same roaming problem. On the Wi-Fi side, we have things like Hotspot 2.0, Passpoint, Orion Wi-Fi, open roaming. And this is all about making sure that people can now roam between their public cellular and Wi-Fi networks seamlessly. And that's happening as we speak. AT&T, almost all our phones now support Passpoint and open roaming. And you don't even know it. When you walk into the stores now that support it, your phone just automatically connects with those SIM credentials from your, either from T-Mobile, Verizon, Samsung, Google, whatever account roaming, whatever credentials you have will roam automatically. This is where we're starting to do that same thing on the cellular side. And this is where Geoverse has those roaming agreements. As you start to understand roaming on cellular world, it's a bunch of agreements on the back end. You have to have agreements. If you want Verizon or T-Mobile or Sprint to roam onto your private cellular network, you have to have those arrangements. And there's like two ways to do it. One is what they call MOCN, where you do it yourself. And the other is where you work with someone like Geoverse who has those arrangements already in place. And this is probably the biggest thing. And another big benefit I see is ultimately, I think most enterprises, they just want to make sure that their employees and their guests have internet connectivity, right? And I think that is the theme here around neutral host roaming, making sure that anyone who's in your building gets the preferred network connectivity that they want. I prefer cellular for voice, but I'll take Wi-Fi when I can't get it. I prefer Wi-Fi for data, but I'll take cellular when I can't get it. That's the experience we're trying to get to with neutral host roaming. Yeah. And I think, Bob, we're almost, we've got one more slide here.
I just built that out a little bit, but we do have, let's see here. No, we're good, Bob. That wraps it up. And then we have one more summary slide after Q&A. So if we want to Oh, I guess open up the mics to the audience for questions, and we'll do our best to provide the answers.
Yeah, Christian, I don't know if you want. I've seen a lot of questions come up in the question window. So I don't know if you want to grab a few and throw them out here. Well, let me just go down here because I seen now someone asked about the spectrum. Is CBRS the same spectrum as the old walkie-talkies? And I think the answer to this one, Bob, this 3.5 gigahertz is typically was the WiMAX spectrum. Originally it was kind of set aside for WiMAX globally, and we're seeing people like in the U.S. repurpose it for shared spectrum. Now, what we're seeing outside the U.S., and this is why it reminds me of unlicensed spectrum, we're starting to see Germany, England, and other countries start to come up with their own rules about how do enterprises get spectrum. So like in Germany right now, any enterprise that wants spectrum can get spectrum for like $1,000 a year or something. So it's relatively cheap. So all the regulators are starting to make it easier for enterprises to get spectrum to deploy these cellular technologies.
Thanks, Bob. You nailed it.
Here's a question. Is Juniper planning to develop multi-RF broadcast O-RAN access point with controller interface capability to, I think from Juniper's point of view, Juniper has an ongoing effort right now around O-RAN. So Juniper is a big supporter of O-RAN. There is currently no plans right now to build a radio or a controller. Juniper did acquire a company called Netsia, which is the RIC, which reminds me of the wireless LAN controller. So this is the function that basically controls the applications on a 5G network. So that's Juniper's current play inside the 5G O-RAN space. Oh, here's one for you, Bob. Do you have roaming agreements in place with all the major carriers?
We have bilateral roaming agreements in place with all the major carriers, with the subtlety being that the conversations that are happening now that are specific to CBRS. So they're commercial conversations, more so than technical conversations with the providers, making sure that we're addressing CBRS as well as all the other technologies that we're deploying and acting as a neutral host for the providers.
Here's another one for you, Bob. I've heard about private cellular networks being deployed in factories, mines, and other locations where public cellular networks are not available. Is this primarily for those difficult to serve or special situations? So maybe Bob, you can kind of speak to, where are you getting traction right now with the CBRS? Yeah.
So it's a good question. I'll address the mining thing first, and there are other areas or sub verticals around that. But there's a couple different within the spectrum. There's low band spectrum, and there's mid band spectrum. The mid band spectrum is the spectrum we were just talking about. The low band spectrum could be 600, 700 megahertz, 850 megahertz of spectrum that covers wide distances where there is no connectivity whatsoever for, let's just say, for autonomous vehicles that go deep into the earth for mining. Because we're a subsidiary of ATN has low band spectrum licenses. We leverage those for those sub verticals like mining. So hopefully that helps. So that is really difficult to serve markets like mining. Low band spectrum is a really effective solution for that. Where mid band spectrum works out is just for all the use cases we spoke about earlier. I'd say that initially where we're seeing the traction is in SLED. And so I'll go back just to 2019, right? The initial premise around spectrum was, let's see if we can address the retail, transportation, logistics markets, commercial real estate markets. And then when the world was put on pause because of COVID, many companies that look like Geoverse pivoted. And we took a look at the outdoor use cases that were available to us to make sure that we were addressing those markets until such time that the world started to take, I'll say, modest steps back to normalcy. And so, a market for us that's been really good has been SLED, and SLED more so around smart cities and then closing that digital divide. I would say that hospitality, but hospitality more so in those remote casinos and even tribal locations where bandwidth is a premium, connectivity is a premium, and it just doesn't make sense for the tier one providers to go out there. Logistics has been an important vertical for us, but not just your typical logistics that you think of, but also those non-carpeted areas for retail, where it's a great complement to Wi-Fi in those spaces, just as a couple examples. And then as we see everything start to come back, you're starting to see things like CRE and healthcare really kick the tires on what's happening with private cellular.
Now here's one about neutral host roaming. I think I spoke to this question, how can neutral host roaming be implemented? And Bob, I didn't chime in here, but I think there's two major ways. If you're a Fortune 10 enterprise and have direct relationships with your mobile operator like Verizon, AT&T, you can use a MOCN gateway and go put your own roaming agreement in place and do that version. For most enterprises who can't negotiate directly with the mobile operator, you're going to go through someone like Geoverse, who has those roaming agreements in place. And Bob, maybe you can talk a little bit about exactly how is that implemented on your site.
No, you're right, Bobby. It's simply through the roaming agreements that we make that happen. They'll hand off the call to us, or we'll hand it off to them, or we do it through a MOCN arrangement, which is a multi-operator carrier network. And so basically what that means is we're connecting our S1 connection of their radio, S1 connection to our radio, and making it look like one network. So as an example, if a end user customer who's using AT&T, they leave their home, they get in the car, they get to the parking lot of a Walmart, and I just made that up, or any large retailer, and they get to that customer, and the customer's handing it, the network's handing it off from AT&T because it's just not a great area, and it's handing it off to a Geoverse, but it still says AT&T on the customer's phone, so they have no idea. It's transparently, that's how that happens.
So the next one here is kind of an interesting use case. It's around CBRS, and can it be used as an uplink to Wi-Fi IPs using Ethernet adapter? And interestingly, if you look at the biggest user of CBRS right now, it's not really LTE. Cambian, which is a point-to-point company out there, was using the spectrum actually for that purpose as a backhaul link into access points, Wi-Fi access points, or something else. So that was kind of the original user of the CBRS spectrum, was around these backhaul. Now everyone I think is moving to LTE. So the answer is yes, you can use CBRS and LTE. CBRS is actually a spectrum thing. CBRS doesn't equal LTE. CBRS is basically spectrum that's available for enterprises to use for different use cases. So LTE is not the only use case for CBRS.
Yeah. And Bob, I don't know if there's any more questions. I can't because I'm in presenter mode, but I just wanted to add one thing relative to neutral hosting and roaming, because I could just feel it through the line. Everybody's minds racing in terms of the different use cases. But, at the end of the day, it's a next generation DAS. And I think Bob mentioned that earlier. So, it's benefiting the user in a couple of different ways. It's about a third of the cost from a square footage perspective, but also just the simple orchestration, coordination of working with the tier 1 providers, whether you want a multi-DAS solution with 3 different providers or just one, rather than you doing that or the customer doing that, a company like Geoverse could act as that broker.
And now here's a question, the same vein around roaming and everything, is about SIM cards. I think, we didn't really touch upon that. As hey, if I've got my private cellular network up and running, how do I provision SIMs? Does the Geoverse SIM roam onto a AT&T Verizon network? How does that work? So maybe Bob, just a little bit about SIM provisioning, roaming. How do we get a Verizon SIM to roam onto your private cellular network, or get your private SIM to roam onto a public network?
Well, we are a mobile network operator, right? So we have a PLMNO number that goes on the SIM card, and then AT&T has a PLMNO number as well. So when you put the SIM card in, the networks recognize that as Geoverse, and then we'll recognize the other providers as who they are. However, when you put the Geoverse SIM card in, you'll basically see a drop-down tool on your cellular device that says, who your carrier is and who do you want to enable roaming to, which provider, and then you pick that, and then it'll roam to that specific provider that you chose after you put the SIM card in.
Yeah. Here's another question, touching upon kind of the ecosystem. Where are we with the CBRS ecosystem? I would say all the latest iPhone and Android devices support what they call band 48. So in the cellular world, CBRS is also known as band 48. So from an operator's point of view, this is yet just another cellular band they can use and deploy. And that's why you see Verizon bought a lot of CBRS Spectrum, right? For them, it's this more spectrum, cellular spectrum to deploy and operate their networks on. I don't know, Bob, you want to add a little bit about the ecosystem?
I'd just say that it's not as mainstream as we would like. I think the last number I saw was about 20% of the handheld devices that are out there today are band 48 and band 48 capable. They're saying by 2022 that's going to skyrocket to 60%. Who knows? But obviously it's just going to go up and to the right in terms of the number of band 48 devices that are going to be available in the mainstream market over the next year to 18 months. And that's not for mobile devices. That's for scanners, rugged devices, tablets, whatever it might be.
Right. And so back to that question, CBRS Spectrum. If you're building a private LTE cellular network, yes, you need to make sure that the endpoint supports that network. And one of the questions you have to look at is 4G, 5G. Right now the cellular industry is in that transition from 4G to 5G. If you're going to deploy a private cellular network, do you support both, one or the other? Do you start with 4G or do you start with 5G? And a lot of that is driven by the use case and the devices that you're trying to get. What is the cost of the device, the battery life, and all that you're trying to use in your use case. Oh, here's a question. Okay, there's a slicing. From which part of the network is network slicing implemented? At RAN or Core EBC? You want me to take that, Bob? You want to take a shot at this?
You can take that, Bob.
Okay, so yeah, so for those who are cellular connoisseurs in the 5G world, in the 4G world, they have a version of micro slicing where you basically slice the spectrum all the way back to the core. Where you basically reserve bandwidth, in the network and in the core. In the 5G world, they've got into what they call RIC, radio interface controllers, and this is where we get a lot more granular control over the radio. And this is where we can start to slice the spectrum in much finer things, so I can have use cases on IoT, voice use cases, and then video use cases totally sliced all the way from the spectrum back to the core. So hopefully that kind of gives you a feel for that question. We have a whole team here at Juniper who's working on RIC 5G slicing. So you reach out to me, I can get you connected with the slicing connoisseurs here. Oh, here's my favorite one. Something about how does accuracy, I think we're talking about location accuracy. Is the Geoverse core ready for all 5G applications? Oh, you're gonna be out here. EMPB, URLCC, EMTC. So I think they're trying. My question is, where does 5G fit on your roadmap right now?
Yeah. So we tested 5G back in December. We actually sent that press release out into the marketplace that we have tested 5G and it tested successfully. So we should have 5G within our Evolved Packet Core, I'd say by the end of this calendar year. That's what we're shooting for.
Okay, well, you see, I'm a location connoisseur, so there's a question about location. How does CBRS versus BLE-based location working? So right now, 5G BLE, what's going on with 5G right now, they have in the millimeter wave, they have some very accurate location technology built into the millimeter wave, almost like ultra wideband. It's not widely available yet, so I don't think you're going to see that for a couple of years. So right now, BLE is still much more accurate than kind of your cellular base station positioning technology. Oh, here we go. This is, we have VLANs for traffic segregation and security on Wi-Fi. Is that available when clients roam in private cellular? And then when they roam to the big cellular carriers? So yes, if you're from the wireless LAN world, we have VLANs and 802.1x basically securing all these devices that are connecting to our network. When you roam into these cellular networks, the authentication is similar but different, right? There were basically doing two things. We're authenticating the device, And with the SIM, you're almost also authenticating the user. And so that's probably the subtle difference between, what you've done typically on your Wi-Fi networks and on authenticating devices with 802.1x before they get onto the network. Over in the cellular world, they also try to authenticate the user because there's usually identity tied to that SIM card. I don't know, Bob, if you want to add anything about security on the cellular side.
I think you nailed it, Bob. The thing about security is that, the SIM is you get that device authentication, and then with the private cellular network, you get the encryption. So, the nice thing about private cellular, it provides that additional security so that if you even are roaming off the private cellular network onto a public provider, you're still never touching that public IP. You're always on the private IP. So you have the security built in that way.
I'm trying to think of a couple more. The CBRS have integrated DAS for in-building coverage. I think we touched upon that. I think CBRS, like I said, CBRS in itself is Spectrum, right? It's a bunch of Spectrum rules. CBRS itself is not a technology per se. The DAS question is more about 4G, 5G, and basically the key to that is really the roaming. Right now DAS is basically usually a passive active cable that goes back to a closet that each operator puts its own base station equipment in. With CBRS and LTE, it's more about trying to move that radio out, that small cell out into your network, and then having all the operators share that same radio.
Yeah, and I would say, Bob, that DAS requires a carrier signal, whereas CBRS does not, and that's a big difference.
Oh, here's kind of an interesting question for enterprises that have a global presence, like big companies that are outside the U.S. Band 48 do we have other allocated bands for 5G enterprise? So in the U.S. right now, it is band 48 for CBRS. If you get outside the U.S., Germany, England, they have different bands for their private enterprise spectrum that they're basically licensing to the enterprises. I don't know off the top of my head, but yes, in the U.S. it's band 48. Outside the U.S. it's slightly different bands, cellular bands. I don't know, Bob, if you have any more detail about bands.
I would just say there's another band that's out there that people may have heard about, which is really the C-band spectrum, which is really expected to be, I'll say, the cornerstone for the U.S. carriers in 5G. And think of it as an adjacent spectrum to CBRS that operates in, I think it's like 3.7 gigahertz to 4 gigahertz range.
Okay, and then there's a question
to confuse everybody else, to confuse everybody.
Yeah, and I see another question from Brian, more detail about 5G slicing. I would say for 5G slicing, please drop me an email, bfriday@juniper.net, and I'll get you connected to the 5G slicing team here. And I think we're almost there. And I apologize if I missed some questions here. I think I got most of them. What regulations are there for installation on in-building CBRS systems? Same for outdoor? I know, Bob, you want to touch upon, there's kind of a power limit, right? You get outdoors, there's a little bit more requirements on transmitting CBRS outdoors than indoors.
Yeah, and there's lower power small cells for starters for outdoor, where there's APs for indoor. That's basically, the only difference that I see on the outdoor versus the indoor. There's probably more, but of what I'm saying, that's the difference.
And so I think we're coming to the end of this. Bob, I don't know if we want to go to the final call to action slide, and we'll start to wrap this up.
So, Bob, if you want, I can take this. But if some of you in the audience, most all you in the audience are Juniper Mist customers. So, a question you probably have in your mind is, well, why would Bob Friday and Juniper be talking about private cellular, when they offer a world-class Wi-Fi solution? Because in my mind, in our mind, it's not an either or, it's an and you can't avoid it, right? It's just like many of the technologies that have been launched in the past. At the end of the day, you can't avoid what's happening. There's inquiries, there's use cases, there's educations, there's questions that you're going to be getting from your leader and your leader's leaders about private cellular. So at the end of the day, regardless of what you do, you need to have a point of view on it. You need to have some type of point of view in terms of how it can work with your existing architecture, how it might be able to apply or not versus certain use cases. So I would just, and I would suspect, I don't want to speak for Bob, but I would just say I would encourage you to continue to learn as much as you possibly can about it, because before you know it, mainstream private cellular and Wi-Fi working together, it's going to be here. And, maybe if you don't do something, people will question, why not? Or, did you do the education, the reading around it? So it's all about having a point of view on these new technologies that are getting launched, and making sure that you can have an opinion on it based on what you learned. Bob, I don't know if you have anything else there.
No, I think, after doing this for years, I think it's another tool in the toolbox, and I think it's going to be a tool that a lot of you out there are going to be using, and I think it's definitely a better together. I don't think it's going to replace Wi-Fi, but I think it's another tool when you're out solving problems that's going to sit alongside your Wi-Fi networks and help you solve problems. So, with that, I want to thank everyone for joining us today, and encourage you, please reach out, to either Bob's here, and we'll hopefully have a chance to meet in person someday.
Thanks, everybody. Thanks for your time.